The first one and mostly the second one. Okay, remember if you're missing terms, you need to fill in a 0 with that term just to help keep organized. And the first step, I'm talking about the top one, number 18. What's the first question that we ask?
How many times is 2x going to 2x to the 4th?
Yep. So 2x to the 4th over 2x. Well, of course, we remember to do numbers and letters separately. So 2 and 2, those just become 1, what we call cancel. X to the 4th divided by x is x cubed. So that goes above the x cubed in our quotient, and then we multiply. So we get 2x to the 4th, and then minus 6x cubed. We're going to subtract that all. 0 minus negative 6 is what? Positive 6. And then we bring down the next term and start over. Okay, next question is what? Round 2.
How many times is 2x going to 6x?
Yep. So 6x cubed divided by 2x. So 6 divided by 2, do the number first. That is 3. X cubed divided by x is x squared. So we'll do plus. I'm going to talk about your quiz next, and some of you would just do this. So if you're looking up here, you would just write the next number down. But we have to have a sign in between because we're creating a polynomial out of our division. So we need to put what either positive or negative. In this case, it's plus. So make sure you're putting that in there. And now we multiply. Negative 6 times 3x squared is negative 18x squared. Subtract that whole thing. Negative 6 minus negative 18. Positive 12x squared. And bring down our 0x. Round 2 is done. Okay, round 3. What's our next question? Okay, 12x squared divided by 2x. Good. Do the numbers first. So 12 divided by 2 is 6. X squared divided by x is x. Okay, make sure again to put plus 6x, not squared, just 6x. Don't just put the 6x up there. Okay, now we multiply. We get 12x squared and negative 36x. Subtract that whole thing. 0 minus negative 36x. Good. Bring down a 3. And last round. What's our question? 36x divided by 2x. Okay, this time all we have to deal with is the numbers. So 36 divided by 2 is 18, and the x divided by x is 1. So it just cancels. So plus 18. Now we multiply. So 36x and negative something. 108, I think. Okay. And then our answer, excuse me, our answer would be x cubed plus 3x squared plus 6x plus 18. That's our quotient, the answer to our division. And then our remainder out of the divisor. How'd you do? We've done this one before, I just realized, but probably didn't remember it till the end. How many of you got it? Give me just a hand. Okay. That was long division. When do we do long division? Yeah, when x is not alone. If it's not just sitting there as x instead of, like this one had 2x. It was close, but we couldn't do synthetic. So if we do synthetic, if you look at this second section, each one of these, x is by itself. Nothing out front, nothing above, just x. Okay, what goes in the little box? 3, good job. Okay, and then we just bring down this first number, the -1, and now it's, for this, remember, it's multiply, add, instead of any subtraction or anything. So 3 times -1 is -3, and then we add 7 plus -3 is 4. And then we get 12, 13, 3 times 13 is 39. Add, we get 37. If I asked you if this is a factor, if x minus 3 is a factor of the polynomial, what would you say at this point? You know, and you know it's not going to be one. So what we're getting into for the second part of the unit is trying to break these down. I've shown you this a couple times. Trying to break this is a 4th degree polynomial down to where we can find all the factors. So if I say, let's divide to do that, and you know right now that this is not a factor, is there any point in continuing? Okay, for the purpose of what our ultimate goal is, which is factoring polynomials, you would stop at this point and just say, no, it's not a factor, I'm going to try something else. Okay? Let's finish this one just because that's why we are here today, but 3 times 37 is, what is that? 111, I think. And then 99. Okay. Quick review of what this tells us in terms of the bottom line. How would I write this as a polynomial? -1 what? X cubed. Because remember we started with the 4th, and so we're going to just drop it by 1 degree, so now it's a cube. Okay, so what's the 4? So plus 4 x squared plus 13x plus 37, and then our remainder looks like that. Okay, but I'll tell you that why we learn synthetic division is not to write it out now, like as we go forward. We're not going to write it out like this. The purpose of our synthetic division is to figure out if it's a factor, and if it's not, we abandon that attempt and try the next one. Okay? So over the course of this week, yeah, I think we'll be able to do it this week. I want you to imagine if I just hand you just this guy. I don't suggest a factor like this one said, try x minus 3. Okay, I don't suggest a factor. I just hand you that and say, please factor this. I want all the factors of this. And hopefully we'll be even to the point where we can start graphing it. I think we will, but. Okay, so what would you try first? Like this one suggested 3, but it didn't work. So what else do we try? That's one of the questions that we'll have to answer. And we're going to have a theorem that tells us what to try. What were we? Yeah, go ahead.
I was going to say like 1 and -1.
Okay, same.
I was going to say 2 just because I know it's easy to multiply by.
Okay, yeah, and so definitely when we get to that, we will want to choose easier ones first. It's not always going to be that way. Sometimes we might have to stick a fraction in there. But we've done that and it wasn't horrible. Okay, let's pause there and look at your test, your quiz. Okay, go ahead and grab your note stuff out. All right, we're going to start into basically our I think, main goal of the unit. And so we have a couple more sections that are pretty heavy on different concepts, but a lot of it is using what we've already done, just taking it to the next level. Our goal, remember, I don't know if you remember this, it's been a while, but our goal was to be able to have me give you a polynomial and have you give a pretty good graph of it by finding the zeros, using those zeros to interpret what the graph will look like, and then using that to write it in factored form and graph. And so our next topic is what we call multiplicity of zeros. It's kind of a weird name, but it's kind of cool at the same time. So you can see it says model and solve problems using zeros of a polynomial. Let's do a quick review. Let's say I give you one in factored form. Maybe it's something like this. And I want to know what the zeros are. So if I said go put zeros on the x-axis, go put points rather on the x-axis for the zeros, what are they? 2, -4, and 1. Good. So we don't have to worry about the fact that they have, like this first one has a cubed and the second one has a squared. It doesn't change that the 0 occurs at 2 or at -4. Now the cubed and the squared do change what the graph looks like at those zeros, but not the fact that the 0 is there. Okay, what would the degree of this one be? Of the whole thing, I mean. 6 degree, right? So like this x will be cubed. If we multiplied this whole thing out, and that would take a while, that would be an x cubed, and then this would be an x squared, and that's an x. So if we multiplied all those together, it would be a 6th degree polynomial. Okay, what is the lead coefficient for this? It's 3, yeah. Is it positive or negative? Okay. So positive. In this case, it's 3. We haven't worried too much about the actual number, but the sign is more important. So this is even positive. What is the end behavior of an even positive? Yeah, so both arms up. Okay. Something like that, perhaps. Okay. The way I've drawn it, we have 3 zeros. I didn't draw it to match these, but there are 3 zeros there. That's not what this graph looks like, but the end behavior would be as x goes to positive and negative infinity, y goes to infinity. Good. Okay, so that's where we've been. Like we need to know the degree, the end behavior from the degree, and the lead coefficient, and that gives us a start on our graph. But what we want now is to zoom in, so to speak, and say what happens at each of these zeros, and how do we know? And our options are going to be the following. This is just a made up kind of situation. We can pass directly through, maybe something like that. Okay, so I'm just focusing on that 0. So one option is to pass through like a line or linear relationship. Okay, one option will be, again, I'm just making up graphs. Another option will be to bounce off a 0. So we'll say bounce, where it kind of comes up, just touches the x-axis, and then keeps going in the same quadrant or the same, either above or below. And then our final option will be, instead of either of those, to kind of curve through, maybe something like this, where it doesn't just pass straight through, but it also doesn't just bounce, it kind of snakes through there. And what would that be reminiscent of? What kind of function? Just in that location, if we just zoomed in right there, what would you call that kind of graph? Well, maybe we'll back up to this one. If I just said, look just right there, ignore the rest of it, it looks like a parabola, doesn't it? So it's kind of quadratic in nature. A parabola. So quadratic zero. I said this one was kind of a linear zero, where it just passed straight through. And what would you call that last one? If we just zoom in, maybe like a zoom box like that. Yeah. Yeah, that's a cubic, right? So it kind of looks like the cubic graph. Somewhat. If we graph just x cubed on our calculator, it would look like that, only this would be the reverse version. Okay, so our goal is to figure out, well, how do we know which is which? And then start incorporating that into our graphing so that we have a more accurate graph. And for that, I'm going to hand you a packet that we'll look at.
You left them at my grandma's house. So Carl wouldn't start there.
Okay. Just before we get into this, I want to make sure you catch the zeros of these kind as well. So let's list them. You don't need to write this, just what are the zeros? What are the zeros of the one up there? And good. Make sure you catch that one out front as well. Okay. So any x's in this is factored. Any x's in that polynomial represent zeros. If it's just by itself like this one, then that would be 0 as a 0. Okay. Remember the idea of a 0 is if I plug in, like in this case, if I plug 4 for x, it makes the whole thing 0. Why? Yeah, because this would end up being 4 and then times 0 times 7, right? If I plug 4 for each of these x's, so 4 out front, and then 4 minus 4 is 0, 4 plus 3 is 7. It makes the whole thing 0. Even though these second two terms are not 0, it makes the whole thing 0. Okay, so that's true no matter where I plug and make a 0. So in this case, if I made this one 0, it would be 0 times negative 4 times 3, which is still 0. Okay, so that's the idea behind zeros. Somewhere in that polynomial, something is 0, which makes the whole thing 0. Don't forget that one out front. That's a big deal. Okay. So on your paper, I might have to add it in here. Hold on. Usually I have it. Nope. Okay. Give me 1 second. I didn't have it added in there. Actually, I'm gonna display. I didn't copy this because we don't really need it, only for like a couple minutes here. Okay. So work with me up here, and let's see if you can start catching on to how do we use zeros to determine what the graph will look like. Okay, here's the factored form of this first graph. It should look familiar. It looks like the factoring of a quadratic. So what is the degree? It's 2. Okay, don't worry about the turning points. Okay, what is the 0 of this first factor? 1. How many times does it occur in our list? Once, okay? And then look at the behavior as it goes through 1. Out of those 3 options that I reviewed on the blue screen, which one would you say that is? Sorry, say that again.
Straight through.
Yeah, it's straight through. So that's a linear pass through. Okay, it occurred once and it passed through straight through. Okay, what's the degree of this next one? That guy, third or 3. Okay, what are the zeros? 1, 3, -2. How many times do each of them occur? Once. And then note what it looks like when they do. How would you describe how it goes through each of those zeros? It's linear, right? And it passes through, linear on all 3. Those are beautiful lines. Okay. What's the degree of this one? Okay, so we have x to the first, second, and first again. So that's a 4th degree polynomial. Okay, what are the zeros? I'm going to write them out this time. And how many times does -1 occur? Occurs once. How about 2? How come? Do you see how it has a squared? That means if I wrote it out, it would have this 2 times, right? I could write it as x minus 2 times x minus 2. Okay, and then 4 just once, right? Okay, now look at the graph at each 0, specifically at each 0. At -1, which occurs in our list once, how does it look? It's linear. At 2, how does it look? It looks quadratic, right? That's a bounce. So 2 things you need to note is it doesn't pass through the 0. It bounces and it's quadratic looking. And of course at the 4, it's linear again. Okay, are you seeing a connection between how many times the factor occurs and how it looks? Okay. What's the degree of this one? Also 4th, right? We have 2x squareds. So this would be a 4th degree polynomial. Okay, you note that our 0, well, what are the zeros first? -2, +3, and they both occur twice, and they both bounce, and they don't cross, right? So 2 things, they don't cross, and they bounce off. Okay. At this point, how would you summarize what we've seen? For your own graphing sake, let's say I give you a factored polynomial. How are you going to know how to graph at the zeros? Okay, if the factor occurs once, how is your 0 going to graph? Linear pass through, like it goes through and it's just linear. If it occurs twice, how is your 0 going to look? It'll bounce. It could bounce off the top, by the way. If that lead coefficient was positive, it would bounce going up instead. Okay, but it doesn't pass through. It just bounces off. We'll look at a couple more tomorrow. This is the first one on your packet that I just handed you. So I want you to do this tonight. It's familiar because it's just a quadratic. We had a whole unit on that. But I want you to think of it through the lens of polynomials. And I will not be setting this up to turn in as a homework assignment, but please, for your own sake, do it. Okay. Yeah.